First, I'd like to welcome everyone to the last lecture of Professor Barry Winkler. Hey! Barry has allowed me just a few minutes for a very brief introduction, so I will be brief. But I just did want to say how much everyone in the Eye Research Institute really appreciates all of Barry's many accomplishments during the last 40.8 years. And not just for his really outstanding research, but also for his very fine records of teaching and service. With regards to his research, Barry is considered by the Vision Research Committee as by far the leading expert in the world on retinal metabolism, and you should be hearing a bit about that today. During the past 40 years, the National Institutes of Health have supported Barry's research with over $5 million in funding, most of this coming from the National Eye Institute, and I expect that Barry will be acknowledging the NEI today. Barry also has a very fine record of teaching, both in the Department of Biological Sciences, also in the Honors College. He taught neurobiology in the Department of Biology for over 25 years, and he's currently teaching a class in the Honors College on Darwin evolution and the scientific theory. And he's also in great demand in the Department of Ophthalmology at William Beaumont Hospital in Royal Oak, and I think we have a few members from that department here today. And Barry also has a very fine record of service, both professional service and also a service here at OU. Barry served on the Vision Research NIH Study Section for many years, and he chaired that review body for a couple of years, bringing great recognition both to OU and to our institute. In 2010, Barry received a very prestigious Distinguished Service Award from our International Vision Research Association called ARVO, and this was for his considerable efforts in promoting vision research throughout the whole world. And here at OU, Barry has been involved in the reappointment and promotion of every single junior faculty member in the Eye Research Institute in the whole history of the Institute. And Barry will be the last ERI faculty member actually able to say that. In 1983, Barry was of great help to me during my first reappointment and promotion. And actually, when I arrived at OU in 1974 as a postdoctoral fellow, one of the major reasons that I really wanted to stay in the Institute, if possible, was due to the great collegiality that I received from both Barry and other Institute members at that time. So I think my few minutes have expired, and now the fun begins. We've all been waiting for this. Barry's been working very hard. Even an hour ago, he said he was still fiddling with his slides. So here we have the last lecture of Professor Winkler.
Well, thank you, Frank. That was really, really nice. I very much appreciate those remarks. Absolutely. So it's clear that if you put the word Brooklyn in the title of a talk, people come. And in fact, just very quickly, initially I had volunteered to fill a gap, nothing more than filling a gap in the seminar program of the Eye Research Institute. There was an opening in March. And so knowing that I'm retiring this summer, I said to Ken Mitten, who was running the program, well, just put me down for March. And that was some months ago, and I gave him a title which was rather research-oriented. And then just maybe a month ago, a couple of people came to me and said, listen, maybe you should make this more into a kind of a last lecture, which, by the way, has been a history here at Oakland sporadically. And so I thought about it at the time, and I figured, well, how difficult could that be, a last lecture? Well, I got to tell you, I have given a lot of invited lectures in my lifetime, but this was daunting. It was part terrifying. And while I'm standing here ready to go, I have no clue whether or not this is going to work. On the other hand, when I'm done, I'm gone. And I might add that as this took shape, several people do deserve compliments. The iResearch Institute and Frank, Provost Verinda Mudgil, and also Donna and Sedona are in the back. And they really, staff people in the ERI, they really propelled this thing forward from the start of sort of editing the flyer, getting that right picture of me, making sure that it looked like a good overhead smash. That had been photoshopped. I was a little heavier back then, but not a big deal. But also some colleagues took some fun. And this was sent to me by Michael Sevilla after he got the original notice of the flyer. And so we just sort of have run with this. So what you're going to get today is a kind of a look back. And it's a bit queer for me to look back because I'm always a person who's looking ahead. The next publication, the next grant application, the next experiment, the next lecture. And so finding a theme for the talk really took a while. But I was able to put together what I think really encapsulates in two sub-themes. The first one at the top is I'd rather be lucky than good. It's an expression we hear a lot of, but I actually tracked down the guy who it's attributed to, and it's Lefty Gomez, a pitcher. Now, I won't give you the affiliation because he was a New York Yankee, and if there's one team that I abjectly hate, it's the New York Yankees. So, rather be lucky than good because that certainly applies to me my entire life, and that is both professionally and personally, the luck has been almost continuous. And down here, taken from a Chinese proverb published originally by Harris Rips, one of the really nice guys in vision research back then and still today, how delightful it is to learn something new from an old problem. And I would say that that really sort of says it so well. All I've ever cared about is sort of making nice new observations, but often built on problems that have been around, but which people really maybe didn't appreciate, or another way of saying it, they abandoned the area and left it for a guy like me. Now, images from 1971. I'm often asked in this last year of retirement, or getting close, well, what changes have occurred? Well, here are some that you're all familiar with. One, the manual typewriter has, of course, morphed into any type of computer that you want. And I was just talking the other day to a former student of mine who was getting ready to write his thesis, and he had no idea that back in the day we actually had to use a manual typewriter. And those of us who are a little older know that when you got to the end of a page, and if you dropped a line, you had to retype that entire page. That was not a whole lot of fun. This turns out to be the typewriter that I used. It's been in my house for about 50 years, and I took a photograph of it. I found it in the basement amongst a lot of other old stuff. And this part on the right is what we in the old days used to use to obtain literature. Now it's a press of a button. You can, put a code word in whatever you want, and within 5 seconds you can get 1,000 papers, and within another 5 seconds you can get 50 PDFs. Print them out, and you're on your way. But in the old days, there was none of that. And so if you found a paper in a journal that you were interested in, you sat down and filled out one of these reprint request cards, and you literally wrote it out. In this case, I don't know if you can see it, but that's to Michael Riley. Riley, back in the day, needed to be, a little boost to his confidence, so I would often send him these anonymously. But the bottom line is that sometimes you'd have to wait weeks in order to get a reprint back. And your return rate was never 100%. In fact, one year I tracked mine, it was like about 25%. So, not to invoke Darwinism, but I would say that that's when I stopped doing it because the return on investment was too low. But we depended actually on Mike Riley. He was the one who really kept this thing going using current contents, a pamphlet, to provide us with all the information we needed to get these papers, but it took time. So it was very different. But then there are some other images over these 40 years that are somewhat more personal. And these are pictures of me starting in 1971 and extending out to 2012. But, I don't recognize these pictures. Not at all. And the reason is that I don't know about all of you who wear glasses and are nearsighted like me, But when I am in the bathroom and I look in the mirror, I never have my glasses on. Never, never. So as far as I'm concerned, what do I see? Right there. That's correct. And for the younger people in the crowd, that's Robert Redford, the great actor. Now, my wife Susan is sitting here today, and she knows that years ago we went to see 3 Days of the Condor, which is a great, great Robert Redford movie. But in that movie, he wore one of those blue work shirts with a tie with his top button open. And Susan knows that the very next day after we saw that movie, yours truly went out and bought a shirt, bought the same tie, and I still have it. So now, where does this kind of hubris or arrogance stem from? Well, you might guess. It comes from growing up in New York. But when you say New York, for example, if Verinda Mudgil comes up to me and I've meeting him for the first time and he says to me, "Where are you from?" I go, "New York City." He goes, "Oh, that's nice." But if Charles Lindemann, who grew up on Staten Island, comes to me and says, "Well, where'd you grow up in New York?" And I say, "Well, Brooklyn." That doesn't stop the conversation. From there, it's what area were you brought up in? What street? Right down to, Google Earth. Oh, that's your house. That's how New Yorkers sort of interact with one another. So, just for geography, this is part of New York City here. Whoops, yeah, there we go. So this is Manhattan, this is Brooklyn. Here's where Charles lives in Staten Island. Here's Queens, or part of it, and the Bronx is up here somewhere. I grew up in this region here called Bensonhurst. Back in the 50s, it was a mixed Italian-Jewish neighborhood. And when I say a mixed Italian-Jewish neighborhood, like most neighborhoods, one street was Jewish, one street was Italian. So you had to sort of make your way around the neighborhood knowing which street to sort of traverse. Not unlike, unfortunately, today in too many neighborhoods. But the bottom line is that Bensonhurst was right on the water, lower New York Harbor. And I was very fortunate because my house, from my mother's bedroom window and my dad's, they were a couple, you could see, and you had a panoramic view of all of this area here. Now, this part here you may be familiar with is now the Verrazano Bridge, which connects Brooklyn and Staten Island. But when I grew up, there was no such bridge. There was a ferry that took you from about here, the Brooklyn and Staten Island ferry. And when you grow up in Brooklyn, as you see here in a little bit high-power view, you actually could come down to the neighborhood park, which was Bensonhurst Park, which was really a wonderful park, and I'll show you a brief picture later. But you could cross over to the water side, and you could literally ride your bike all the way down to the Staten Island ferry, and you could go across. And I'm telling you that I was doing this from the age of 10 years on. My parents never worried. It was a simpler time, absolutely a simpler time. And friends and I would take the ferry across to Staten Island, which gives you an incredible view of Manhattan Island, and it was a fabulous time. The other thing about growing up in New York City, which was so vital to me, public transportation. And I just highlight two things. One, we have neighborhood high schools, of course, in every area, but I went to a high school that was located on the Lower East Side of Manhattan. It was a special science and math school, supposedly the best school in New York City. They only took the top 1% of all the kids in the city. Now, seriously, do I look like a top 1% kid? This was something the principal told you to perk you up, but once my parents heard this, that was it. I was in the top 1%, except when I brought home my grades. But I could go by public transportation. 1 hour, took 2 trains every day, and I started high school as a 10th grader at the age of 13. Again, my parents, no worries, get on the train, you could stay after school, come home, no big deal. And the second highlight is this S over here, which you can imagine, stands for Susan, because I met her in Brooklyn at the age of 14 years old. I'm not allowed to give any details of that first encounter, but clearly it was good. But she lived in this neighborhood here called Flatbush in Midwood, and again, it was a 2-bus ride, but my mom and dad, very cool about it, no problem, take the bus. They gave me a curfew. If I was late, you call, no big deal. Life was really good. Now, as I mentioned, I was very fortunate to grow up in a private house. And for those of you sitting in the audience who have never been to New York City other than seeing, films and reading books, you probably have this opinion. It's a high dense population, lots of apartment houses, really people clustered together. Well, I was one of the lucky ones. I lived in a modest house. I'm sorry. You're right. That's my summer home. Sorry. But in fact, I grew up on a street that was a row houses, but they were all private homes. This is my actual street, taken in a recent photograph. This is my parents, Al and Rosalind Winkler, and I have the date on there because I'm a smart guy, and that happens to be the date of our wedding. And that's why my parents are so happy. We were gone. But this was a street like most others in Brooklyn, except for a couple of things, and just two highlights. One, every house, or nearly every house on this street, had 2 or more children, one of whom was a guy, and we were all within about 4 years of each other. So I grew up on a street where there were close to 15 to 20 boys within 4 years of each other, very competitive, and we were always out on that street. And we played square ball, we played box ball, we played punch ball, and we played stoop ball, and we played the most famous indigenous game of Brooklyn, stick ball, with just a rubber bouncing ball and your mother's broom that you simply soared down because we were small in those days. Of course, it was a little tough then when my mother wanted to reuse the broom and she was sort of leaning over. But a couple of things. Check out the purchase price. In 1945, look what it's worth today. Now, would you buy my house? Yeah. But my parents were smart. Why? The water was over here, and therefore the back of the house looked at the water. These people had no view. They just looked in my window, and, depending upon, occasionally the guy across the street or the lady across the street would, oh, I have to pull the shades down. But not a big deal. So this was growing up there. We were always outside on this street, and you learned the competitive edge amongst your friends. And stickball has always been in my blood. And in fact, the New York Times, again, these are things nobody really knows about, but the New York Times wrote a wonderful article on stickball. And I was so compelled that I wrote a letter to the editor. And what happened was they had almost 1,000 letters in response to this nostalgic article. And they picked 5 letters to publish. And one of the 5 was mine. And if you Google the New York Times and put in Barry Winkler, this is one of the things you get. I also have written a second published letter in the New York Times. And this was when Duke Snider, the great Brooklyn Dodger center fielder, died last year. I know this has a lot of meaning to at least 2 of you. But when the Duke died, I wrote a letter to the editor, and that too was published, along with many, many letters. So you can see that in the midst of all of these world crises, what is it that turns Barry Winkler on? Things like this. So now, if I wasn't on the street, I was in the neighborhood park. And as Greg Campy, our basketball coach, is here, he knows the value of being able to play on the #1 court in any public playground. And boy, you had to be tough to get on this court. But look behind the court, and you see this cement wall. And that cement wall is a 1-wall handball court, which again is, we have in Detroit area, mostly 3-wall handball courts in Detroit area, like if you go to Belle Isle or Southfield. But these 1-wall handball courts were a feast for little kids and adults. And what you see here is a pair of handball gloves. Those are Brian Murphy's gloves, because Brian Murphy and Mike Riley and me and a few other people, Julie Gendel, who's retired, we had an incredible run of about 30 years, there's Brian, of about 30 years of playing handball together. And all you needed was a good pair of gloves and of course, some skill, which Brian lacked. And here on the basketball court, black high tops are back in. That's what I wore. And in fact, Susan's been after me to get rid of them after all these years, but I just can't part with them. So this court was where you learned your skills, and it turns out I really liked basketball. And I managed to play for my high school team at Stuyvesant. I played 3 years and had a good time. But you see our gymnasium. This is what our basketball court looked like. There was a surrounding track and these pillars. That's right. Remember, Stuyvesant was built back around 1920 before they even had basketball. And those pillars were very structural because all Stuyvesant was a building in New York City, as if you were walking down any street. It was just a building. If you walked by it, you thought it was an apartment house. So this was structural to the building, but boy, you took your lumps. If you didn't like somebody, you pushed them in there. And while there are some supports here, they were not very helpful. But the bottom line is we had absolutely no home games. So as a kid, no home games. We had to play away games and often as our home game. So we traveled to all the boroughs of New York City except, again, sorry, Charles, Staten Island, because of the ferry, I assume back then was a little tricky. But the fun part is that there was no bus that took us to a game. And the coach did not work in our high school. And he would give us directions. I mean, 15-year-old, 14-year-old kids, he'd give us directions on by train or bus, public transportation. And there were times, if any of you have traveled to New York City, like 4:30 in the afternoon when much of our games were played, those trains are crowded. And you're walking along with 10 guys with our little gym bags, you know, and our Stuyvesant caps. Not every time did the whole team get on the train. And one time I remember about half the team didn't show up till halftime because they got lost. So that was the system under which I learned to play ball. As I said, Stuyvesant, very big in science and math, and that was really my strength, my aptitude, if you will. And after Stuyvesant, by the way, Stuyvesant, just so you know, 99.9% of our kids always go to college. One other thing I didn't mention is it was an all-boys school back then. How's that, ladies? It was an all-boys school. Now it's co-ed. And I do admit that when I was there in the early 60s, I did lead a petition, because I like women. I did lead a petition that it should be co-ed. But it took 20 years or more for them to finally allow girls in. And now the school is, like Oakland, there's a majority of females. At Harper College, which is where I went, Harper College is a small liberal arts school, or was a small liberal arts school. Now it's like Oakland in the sense that it has grown by leaps and bounds. Very, very fine academically. But when I went, just to give you a feel, there were like 600, 700 students there. So it was really small college. Unlike Oakland, we were not a commuter campus. Everybody either lived in the dormitories or in apartments nearby, and it really had an atmosphere. And so I was fortunate again to play all 4 years in college. And as you know, I am retiring, and I did invite Greg Campy, because in case one of his assistant coaches, you know, people are always asking me, Greg, well, what are you going to do next year? And I was thinking, well, you know, I do know a little bit about basketball, so. But now for the students in the room. You all know that college, you have your good years and your bad years. And I don't even have to look at this slide for you to know which was my best year. But the reality is that those 4 years go by like a shot. We know it. The students in the room, maybe there's some freshmen or sophomores, you don't know it, but it goes by like a shot. And the trick during those college years is to find something that you really are invested in. And by that I mean where you can get, again, a little lucky. I was very lucky in the sense that I was a science major, but I took a course in physiology, and the professor was unbelievable. And again, I mean, there are many professors in this room, many of whom are wonderful. This guy was just incredible. He was kind to students, he was smart, and when he found out that I really liked it and did real well in the class, we sort of got together. And it was this fella, single-handedly, who really steered me. He knew I was interested in one other thing. I really like the lifestyle of college. I really like the lifestyle of professors. When I was at college, it looked to me as if they worked maybe 10, 12 hours a week. And I only say that now because it hurts me after 40 years that the public perception that many of us who work our tails off, that is the perception of society in many ways. And it's always bothered me. Even though I started with that perception, I quickly lost that perception as soon as I went on to graduate school. But this professor was able to steer me to a really first-rate graduate program. And as Frank and Jane Giblin know, because Frank also went to the University of Buffalo, he was in biochemistry, I was in physiology, nearby neighbors, although we didn't know each other. He came a little bit after me. But that's Susan, back in the old days, cleaning off my car. That's why the relationship has lasted this long. And then the most important part of the second phase of the talk. It gets a little serious, but not really. Werner Knoll, right here. When I went there, as all of us know on the faculty, when you go into a graduate program, you don't have a clue, at least I didn't have a clue, exactly what area of physiology I was interested in, who I would work with. I just was told by my Professor Trumbore at Harper College, this is an excellent first-rate department. And he was right. There was a Nobel Prize winner in that department. The chairman of the department was the president of the American Physiological Society. 2 other faculty were to become presidents of the American Physiological Society. This was a high-level department. I had no clue what I even liked. I liked all the areas of physiology. But Werner was the neurophysiologist. You'll see he has an MD. He was a neurologist by training in Germany, so he fought on the other side in the war, although he swore to me and his other Jewish graduate students, I fought for the French resistance. And we believed him because I wanted my degree. But you can see this quote here about looking for the unusual and the oddity, which I'm sure you've all had a chance to peruse. That's not exactly what he said. This is my interpretation of what he mostly said to me, and that was, "You idiot." And as the guys know, Ken and Mike and Frank and Reddy, who have met Werner over many years, they know exactly that that was what he used to say to me. But the bottom line is that I was very lucky. He took me under his wing, and he was the guy. We had other graduate students, postdocs. He had an enormously large operation for the 1960s. But he was the guy who really taught me how to find love in doing an experiment. And that's what it is, which many of us have, a passion and a love for what we do. And it was really through his pushing and his constant challenging that I really grew. From someone who went to graduate school thinking, you know, I'd be working about 10, 12 hours a week, teach a couple of classes, play ball in the gymnasium, you know, I knew the coach there too. Hey, this is easy. But in fact, once you hook up in these types of areas, you know you are basically giving your life to this level of research. And when I joined Werner, his laboratory addressed electrophysiology. And I show you here just, and don't worry about any of the data today or the tracings, but two things you're familiar with. You've all heard about an electrocardiogram and EKG. You've all heard about an electroencephalogram and EEG. And these two waves, these two types of recordings have in common that they can be recorded non-invasively. You don't have to, you know, drill a hole in the heart. You don't have to drill a hole through the skull. You put electrodes at distant sites from the sources of the currents of these potentials. And the same is true, it turns out, for the electroretinogram, abbreviated ERG. It's a very simple recording technique, but the waveform is actually quite complicated, and it's been analyzed for many years, still being analyzed. But when I came in the field, we knew that maybe the first portion of it comes from the photoreceptors, and the second portion comes from deeper in the retina. No big deal that you know this, but it's complicated, and you have to sort of dissect out the varying components, and it depends on lighting conditions and all this other stuff. And so I started off, like I said, you put an electrode on the cornea here, one electrode behind the eye, and you can give a light flash. You're in a dark room, and you can make a recording. And that's how I started my life in research. I was doing EKGs, I was doing EEGs. I mean, I was doing all the electrophysiological testing. But I was also slowly compromising my health severely. I started work with rabbits and rats, and I am severely allergic to the animals. And so after about a year of working, I came to Werner after my allergist said to me, you just can't keep doing this. And I said to Werner, I can't work with the animals anymore. And he said to me, as only a really caring mentor could say, well, what are you going to do about it? And so Werner proposed to me, why don't you see if you can get a retina out of an eye and see if you can figure out how to record from an isolated retina, and then you'd have the animal with you for just a few minutes, you anesthetize the animal, and then you get him out of the room. And so it turns out that if you take away the cornea, and you take away the lens, and you take away the iris and the ciliary processes, you're left with what is called the back half of the eye, called an eye cup. And what I was able to do, almost stumbling on, was to develop a procedure to rapidly and reliably take out and separate the retina from the underlying cell layers. And this is just a cross-section of the retina. It's about 200 microns in thickness. This is the front part of the eye. This is the back part of the eye. But basically what we were able to show is we could get a retina out, and we could make recordings basically demonstrating that these tissues were alive just as if they were in the body. Meanwhile, my contact time with the animals was very limited, and it looked really good. When I first published this technique, an interesting thing happened. I began getting phone calls from people in the field asking if I would come to their laboratories to show them the technique for rapidly removing the retina. And as the research technicians and others in my lab know, it is a ridiculously simple technique. It was luck. It can only be used on this one species. It doesn't work in a rabbit, it doesn't work in a frog, it doesn't work in a pig, and luckily it doesn't work in the humans. Otherwise I'd have a lot of subjects. So I did. I had the good fortune to share my experiences with quite a few labs. And the paper was published in 1972. And 30 years later, I get a call from Matt Lavale, who, again, the vision researchers will know is one of the stars, along with Gene Anderson, two good friends of mine. But I get a call one afternoon from Matt Lavale. Listen, Barry, you know, Gene and I feel we've never properly thanked you for showing us the technique that we have been using as a staple in our lab, which we have passed on to students, postdocs, and we want to thank you. So we want to label your technique, which this is a direct quote from the paper. I wish they would have bolded it and enlarged it, but there it is. They called it winkling. And so now I just recently came back from Case Western Reserve about a month ago, and one of the professors said, you know, they met me and they had a student, and the student said to me, "Are you the Winkling technique?" So there's some ways to be famous and enjoy it, which of course I did. So now, what I was able to show, again, don't get hung up on this, but just to show you, these are waveforms that we could record from isolated rat retinas. And they really were very similar to the in vivo, in-body experiences. And we could keep these tissues alive by perfusing them with a blood-like solution, oxygenated with glucose, a nutrient. And what we were able to do was to show that we can keep these tissues going for hours. And now many people use these types of preparations. They use slices. There's a whole new array of technology. But it all starts with you convincing your readership that you can make good recordings, no matter whether you use extracellular techniques like this, or intracellular, or patch clamp, or any of the other newer techniques. But you have to demonstrate that you can reliably do this. So my graduate student days, as we all know, once you get results as a graduate student, it's boom, boom, boom. Suddenly, you know, that tunnel looks, you can't even see the light at the end of a tunnel when you start a PhD thesis. And I see Dean is shaking his head. Did you ever see the light at the end, by the way? But the bottom line is, once you see that light at the end, you know you're going to get your degree. I mean, it's a foregone conclusion. You just got to keep working. But there was a huge cloud in the late 1960s that hung over all of us. And that was the Vietnam War, which I know many of you young people, it's not even something you think about. But I will tell you, considering we're fighting two wars now, the wars we're fighting now, you notice you don't even hear a ripple on any college campus. Not a ripple. And that's, of course, because we have a volunteer army and it meets the quotas of all the armed services. And we should be very grateful to that. But back then, as Mike Sevilla and I talked the other day, December 1st, 1969, they were not filling their quotas. They were ratcheting up the Army call-ups for all the branches of the service. And they held the first draft lottery since World War II. And, you know, you'd think that this was like American Idol. They put a big drum on the table. They filled it with 366 dates. And this guy from the Selective Service, he went in and he would just pick one after another and put it up on the board. And as you can see, the first date he picked was September 14th. Well, you can see, you can all guess what my birthday was, right here, April 17th. And as they went through this, boom, 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 the word had gotten out through the Selective Service that if you were in the first 195 dates of birth selected, chances are you were going to be drafted. Now, about 3 weeks before this, and Susan, I don't even think, probably doesn't even know this. I probably didn't tell her. I got a letter from the draft board, in Brooklyn, no less. I'm up in Buffalo, but you retain, as you must know, you retain your local draft board. And I'd been going back and forth with them about my asthma and how I couldn't possibly be running around Vietnam breathing the air from the napalm and breathing. But they didn't care. I was classified 1A. They did away with any deferments, and I was waiting on this. They were scheduling a meeting when this night happened. The beauty of this night was this was a one-time thing. So if your number was above that 195 cutoff, you were no longer eligible for the Selective Service. So the next year when they did another draft lottery, you weren't in it anymore. And as Mike Sevilla and I was talking to, I don't know where Mike is right now. Oh, there he is. There's a lot of gray-haired people over there. But the bottom line is that Mike and I were, we were in the same draft lottery. What was your number, Mike? Remember? Yeah. Over 300, so he was safe. So when they announced that I was a 260, I then knew I was safe. Now, I can tell you that within about 5 minutes of them posting this number, Amy was conceived. You may laugh. This is probably the most truthful thing I'm saying here today. But the truth is, Amy, when were you born? August 10th, 1970. That's darn close to 9 months, and I know what happened 5 minutes after that posting. Now, I speak about the campuses today. They're really dull. There's not much happening. I mean, we got a political thing going on around us, but you don't hear too much on college campuses. But back then at Buffalo, right after the draft pool was announced, there was big problems throughout the country. Buffalo was one of the most activist campuses. We had police on the campus 24/7, and as you read, you'll see Project Themis, which has no meaning to you, but Project Themis was a Department of Defense funded grant. And which department do you think this money was given to? Physiology. It was an attempt to look at high and low pressures on the physiology of divers, and of course, as we were working towards move astronauts to outer space. But that didn't matter. It was funded by the Department of Defense, so our department was a huge target of these activists. And I knew a couple of these people because I used to play pool in the student union with some of these students. Another big difference today, you don't see any hangers-on campuses. But in our day, in the 60s, University of Buffalo was populated by a cadre of people, young people, men and women, guys and girls, who dropped out of college, but liked hanging around the student unions. And this was true at Berkeley, this was true at Wisconsin, this was true at Buffalo, you name any of the activist campuses. So there were a lot of people running around. And all I did was point out to a couple of these people in the demonstrations which windows were my laboratories. And I was very fortunate because those were the two windows which didn't need to be boarded up. Oh. Now, I finished my PhD. For the electrical engineers in the room or the physicists or anyone else, it's a simple model, but we provided a lot of quantitation for it. And I was also, again, very lucky. Why? The department chairman liked me. And so well before I even started writing my PhD thesis, I was offered a job as a faculty member in the Department of Physiology Medical School. And again, for those of us who are working or had worked on writing thesis, what's nicer than already knowing you have a job which didn't even depend on the date of finishing your thesis? And so I stayed on Buffalo, and I had a 2-year appointment. But during that first year, Werner Knoll, who I was having space in his laboratory, said to me, you know, you really should think about moving on. It's important for your career. You shouldn't stay here. If you ever want to come back, that's different, but make a name for yourself first. And so I did. We began to look for jobs. We had Amy already, which was great fun. And so I looked around. And then one day, Werner comes to me. Two guys I never heard of, Everett Kinsey and Van Reddy. He gets a call from Everett Kinsey. And what it is that he tells me this institute had just begun a couple of years earlier, and they were looking for a retina guy, and would I go out and interview? And I asked him where it was, and you know, just like for all of us, Oakland University, doesn't matter. Oh no, go, just check it out. So I get a call, and I come out here. Now, everyone in this room, the provost is here, knows what a process it is to get hired now at Oakland University. You bring on 4 or 5 candidates, you send them on their way, you wait 4 months, the faculty get together, they do this, they do that, then they send it up to the dean, they send it up, and it's 6 months before someone even gets an offer some of the time. Well, compare that with my experience. I come here, and the only people who were here on the faculty was Dr. Reddy, who's sitting right there. Did you see what I wrote, Reddy? Still looking good. Did you see that? And that's true. The man is going to be almost 90 years old. It's incredible to me. I wish I get to be 90 like that too. So I come and I give a seminar. Michael Riley's there, Ben Reddy, Everett Kinsey, and Chuck Rapani was there, John Redden was there, Nalin Yanaka, about, you know, not a big crowd, nothing like this. At the end of the seminar, Everett says to me, okay, we're going to go to lunch. And where does he take me? Just him. I never have forgotten this. Just him. He takes me to the student union for lunch. Not the student union are in here today, but for those of us like Dick Haskell and me and others, that student union, the cafeteria was in the basement, and all you could order was, I don't want to paraphrase John Belushi on Saturday Night Live, but you either got a cheeseburger or a cheeseburger, if you remember the great Saturday Night Live stuff. But that's true. So I had to take the cheese off. But meanwhile, Everett, as the people in the Eye Institute know, he always brought his own lunch. He ate before my seminar. That's right, Mo. And so here I am being interviewed for this job, and he's telling me eat. And I'm just, you know, how do you interview while you have food in your mouth and then soda? And because he told me to get whatever I wanted. I didn't know he wasn't going to eat. At the end of this, I figure that's it for this job. We go back to his office, and he shuts the door, and he says to me, you have the job. So I figure he broke every rule of affirmative action and whatever else we call it around here. But that was it. He said, you have the job, go home and think about it. And oh, one other thing, we'll need your grant application in 3 weeks. That's a true story. That was a true story. But he also said a couple other things to me, which is really critical. And that is, go in your room, you pick out a lab, and we will leave you alone. All we want you to do is to develop a laboratory in retinal research, get funded, of course, but we will leave you completely alone. No teaching, no committee work, and thank you for those comments on that, Frank. It's true. And that model has held through all of the administrations, including the present administration with Gary and Verinda. They have adhered to that model to leave us alone to try to do the things we do best. It couldn't have worked out better for someone like me, whose personality is, I just want to be left alone. I just want to do my thing. I don't hurt anybody. I just want to be in my lab, as my students know. So it was a marriage, and Kinsey kept to it. We had only one disagreement in the 7 years or so, 8 years until he died. An untimely death, I might add. He was not that old. And we had only one disagreement. I did come to him after my second year here and say, you know what, I need to teach. I need contact with students. And Everett and Reddy after him balked. They didn't want me, not that they didn't want me to teach, it's just that they felt that anything that took you out of the lab would be detrimental to you sustaining your program. But the reality is that he did relent, and I'm glad he did, and Frank is right, I did teach neurobiology for many, many years. So now, I come here and I'm given a lab, and they gave me a choice. And the institute back in those days was half empty. But I found out where Mike Riley's lab was, and the one next to his was empty. And both of ours were on the corridor that was opposite where Kinsey and Reddy's labs were. And there was an exit stairwell. I'm not even going to complete the sentence. So, I came here and I continued my electrophysiology, but my interests changed, just as everyone in the room. Your interests evolve, they change. And I became much more focused on photoreceptor cells and their behavior, both electrically, but also metabolically. And as Frank says, that was very nice also about the metabolism. And I'll just share with you just a couple of things of what I've done and how the career has evolved. Nothing heavy. The bottom line is, to me, this is the most beautiful cell in the body. It's a photoreceptor cell shown as a living cell, obviously amplified and magnified. But on this side are the electron micrographs, high-powered views of just this part and this part of the cell. And then here what you see is an even higher power micrograph of the outer segment part of the cell. So there's an outer segment and an inner segment. There's a cell body like all cells have, and then there's this terminal where information is moved on to the next cells in the chain. So when light comes into our eyes, it's absorbed only along this region of the cell. And it does so by having molecules which are imparted to these membranes that absorb the light. And as you can see here, this array looks to be similar to having pancakes stacked one on top of another. And in our eye institute now, we have several guys whose focus is just on the outer segment of the photoreceptor cells, which is a very, very important area. Now, the inner segment is totally different. The inner segment shown here in cross-section, so if you make a cut here and just look face on, this is a cone inner segment, see much larger than a rod inner segment. Rods are more numerous in this section. But this region is packed with mitochondria. There's no other cell in the body, no other tissue in the body that has such a dense packing of mitochondria. And for those who are in the non-science group, the mitochondria utilize the oxygen that comes in across the cell membranes and makes energy. So the prevailing opinion back when I was first here at Oakland University was, with all these mitochondria here, this is where the energy is produced, and it will flow out this direction, it'll flow out this direction, and keep cells happy. So we did a simple experiment. And that is, we began to record receptor potentials and post-receptor potentials. And all we did was say, okay, if oxygen is so important to these cells should not be able to continue to function. Nice hypothesis. But what we found was, as shown in the conclusion here, so this graph, this is the 100% point in the control, then we simply purge the solution of all the oxygen and replace it with nitrogen. And we look to see what happens to the responses we're recording. This is the control. The A wave is the receptor potential component, and this B wave is the post-receptor. And you can see that within 5 minutes, the post-receptoral potential disappeared, incredibly sensitive to the lack of oxygen, as if this network had no reserve capability. But the photoreceptor potential continued to stay up. It's not at 100%, but this was a pretty steady state response. And as you went out in time, 30 minutes, 1 hour, the system continued to function without any oxygen in its environment. And when we published this result way back, it met with, wow, could this be right? Well, the answer is it's turned out to be right. But where it had its impact on me was it completely changed my laboratory. And for this, what I had to do was And this is, I worked very hard to get this summary slide right, so I hope it's helpful. But it is really a simple approach to any of the scientists in the room. But you know, timing is everything in life, and I just happened to come along, and I say this in the most humble way. I just happened to come along when there was virtually nobody doing electrophysiology of photoreceptor cells and metabolism. And where I was very lucky, and hence their pictures, Mike Riley and Frank Giblin. First, Mike. I wanted to then begin to say, well, why is this cell so resistant to blocking the utilization of oxygen? They don't need mitochondria, but they need glucose. And it was Mike Riley who took me in when I came to him with this problem. He had already had experience in this area when I was just a boy. I mean it. When I was just a boy, he was already doing this stuff. And what Mike O'Reilly showed me was how to make some of these measurements of the metabolism of glucose, what we call classical biochemistry today. But again, you remember my graduate student days, I was an electrophysiologist. I took medical school biochemistry, but I wasn't a metabolic person. I was an electrical recorder. And so Michael was extremely helpful in allowing me and giving me the tools and the encouragement to make these types of measurements. Similarly, Frank, who was coming along, and he mentioned 1983. Well, the fact is that Frank and I made the first measurements of this compound called glutathione, which is the most important antioxidant in cells in our view. But we made the first measurements of glutathione in a retina. But it was a whole tissue measurement, and I'll come back to that in a second. So what we've done over the years really is to make measurements of all of the metabolic end products of glucose, and it just happened to turn out that when we looked at amino acids now, we know amino acids are neurotransmitters. So we were beginning to look in quantifying the production of amino acid neurotransmitters, which was vital for one cell being able to contact another cell and pass on its information. Because don't forget, I'm at the level of the eye, photoreceptors, the first cell in the chain. But visual perception occurs in the visual cortex initially. And so there was much staging of processing. So as you know, it wouldn't do you much good if your photoreceptor cells were really doing well, but some other part of the pathway was not functioning, you still would not see very well. And then we looked at oxygen uptake and carbon dioxide production. And again, as Frank pointed out, just with a deep appreciation to NEI for many years, and Oakland too, because I don't have a record of continuous funding despite $5 million. By the way, I barely have any of that in my pocket. But the reality is that Oakland supported me in years when I didn't have a grant, and they did not ask me to teach either, which I thought was very, very fair. Of course, I felt I earned it, but what the hell. Okay, so now, to come full circle with the last two slides. I mentioned to you about Werner Knoll, and it always telling me to look for the unusual and the odd. And really, the beauty in science, to me, is you never know what tomorrow brings. You never know when you're going to make a really interesting, exciting finding. Sometimes it comes from reading a paper where you scratch your head and go, can this be right? Sometimes it comes by a little luck. You picked the wrong chemical off the shelf. You know, you wanted to look for cadmium, and instead you picked calcium. And something works. In this case, what you're looking at here, very simply, is a technique called immunocytochemistry, in which you use an antibody to tag a protein, and then you use another set of techniques in order to bring out the image of that reaction. And what you see here is a whole retina from here to here. The dark regions, as you can see, are those areas that are chock-a-block with glutathione, here and here. But then you see this whole region here, which are the photoreceptors from the outer segments to the terminal. They did not have glutathione. And there were papers appearing in the literature which showed this result from different labs. And scientists are funny in some ways, and that is, we only want a result. We only want a positive result. You can't do much with a negative result. You can't prove it. You don't want to touch it. You can't get a grant on a negative result. And so when I read these papers from different labs and I knew the people, they only talked about where glutathione was present and not where it wasn't. But for guys like Frank and Mike and me, this was a surprise. How could it not be present in photoreceptor cells? Every other cell in the body has it. And so yours truly knew that I couldn't get a grant on a negative finding, and so I had to do a lot of thinking. And for this, I'm also grateful to Art Bull and to Mike Sevilla, because I dragged them in on glutathione and reactions in the old days, and they were very, very helpful to me too. So we began to look at how could it be that there's no glutathione in photoreceptor cells? Why wouldn't the cell want it? In fact, the photoreceptor cell is the most vulnerable cell to oxygen damage in the retina. And it took a while, and to make a long story short, and something I'm very proud of, a couple of years ago, I wrote a hypothesis paper. And one of the things that I didn't point out in the earlier slide, but I will now, one of the most interesting things about an outer segment is that it renews itself. Every 10 days, we make a new outer segment from the bottom where new membranes are being made all the way up to the top. Now, a photoreceptor cell is what we call post-mitotic. It does not divide, but it does renew this entire region of the photoreceptor cell. The inner segment, the cell nucleus, and the terminal do not renew. They renew some of their components, but not the entire organelle. And this has been called rod renewal, and it was discovered in 1968, many, many years ago, by Dick Young. But no one has tried to provide any explanation as to why these cells undergo such a transformation daily, because there's an energy cost and other costs to the cell. And ultimately, without going into any detail, we proposed a hypothesis to account for the renewal. And what was very cool was, it was published in Investigative Ophthalmology. I actually sent this paper to them. I didn't know, how to send it. It's only 3 pages, but I didn't know how to send it. So I sent it as a letter to the editor, because they take interesting things. But when the reviews came back, and this is the only thing where I'll say something, where maybe it's a little less humble, but not intentionally. When the reviews came back, the editor of the journal called me, and he said to me, listen, Barry, we don't want to publish this as a letter to the editor. We want to start a new section of the journal called Perspectives. And for any of you who go back to this journal, this was the first issue that contained a whole new section in the journal called Perspectives, which they now do every single month. They have chosen essays. And I was like, wow, cool, I was really blown away. So that was nice. So now I come to the very end, and in a timely way, for my thank yous. So that's been my career. Very straightforward, lucky in many, many ways, starting as an undergrad, Werner Noel, who, by the way, passed away in 1992, but I remained like this with Werner till he died. And I had the great pleasure, to the extent that you have a great pleasure of this, of writing with another student of his, the obituary for Werner, which appeared in all of the ophthalmology journals. And there was a little bit of humor in there, too. So, some thank yous now, because you never do this alone. And I would argue, I happened to go to the wonderful Hall of Honor dinner, and Pete and Greg are here today, and Mike Riley and I were there. And it was really beautiful to listen to those 2 guys speak about their careers as coaches and their relationships with their students. But I have to tell you that I've had incredible relationships with these 3 guys. I mean, deep, intimate relationships. So here's Ken Hightower, who is now the Dean of the School of Health Sciences. Here's Frank Giblin. Here am I, and here is Mike Riley. This was taken back in the 1970s, and since I actually have a few minutes on this slide, I just want to say one funny story. I could do many, but I'll just do one. So the beauty of working with these 3 guys was the following. We all loved sports, but we all loved work. We all liked to party, we liked to drink, and we liked to fool around. And we did all of those without moderation, let me just say that. But the best fun that we had, the 4 of us, was that every year we'd go to the annual meeting of research in ophthalmology. And in those days, we didn't actually have a lot of money. And I might add, I still don't. But we'd share a room. And we stayed in some hotels where, you'd say, oh, they rent by the hour. No, we went to places where they rented by 20 minutes. And one year, the 4 of us, well, we did this for a bunch of years, probably 15 years, but one of the years, I snore. And I have a sleep apnea, so I have a CPAP and all of that wonderful stuff to share with an audience. But the bottom line is that back in those days, I was snoring. Now, in those rooms, you can imagine how small they were when they went by 20 minutes. You don't even need a double bed, I suppose. But we would share a room with 2 beds, 2 double beds. Typically, Frank and Ken would sleep together because they had, something going. And which, by the way, never bothered Michael and me. But Mike and I would sleep together. And it turned out one night they just began throwing all these pillows to try to break me of snoring. And I throw them back. And about halfway through the night, I realized how dumb. I'll keep the pillows. And I did. But then they grew tired of this. And what they did one time was I came back from the meeting, and I came in the room, and they were all sitting outside. And I came in the room, all my stuff was gone. And what they did was they bought a room about 6 doors down, and they paid for my room for the whole week so that I would not sleep with them. So that's the story. Now, one other thing you should know, because, these guys are pretty serious. So we had different tasks when we would go to these meetings. Frank, and Reddy will be happy to hear this, was assigned to go to the meetings. Believe me, I'm in this too. So Ken and I were assigned to find any and all tennis courts in the area, specifically those that had lights, so that we could also play at night, which we did find. But the best was the Englishman, Mike Riley. What was he assigned? He was assigned to find every free buffet within 20 miles where happy hour was free. And I got to tell you, there's no one better than Mike Riley at finding free food. So now, we do dress up. And this was taken just a little over a year ago in honor of Everett's widow, Irene, providing a bequest to the Eye Research Institute. You can see the fellow who does not belong in this photo. This guy here was not an original member, but he paid for the framing. And he's laughing. He's laughing. Okay, so we also had, in the early days, NIH paid for secretaries. And Mike Riley, of all the people, and Frank, they never typed. So Ken Hightower and I, who did type and did our own work, we still had to chip in. And NIH was very nice about providing secretarial help. And Roxanne, who's on the campus and the dean of students, and Alice, who is in the math department, were really wonderful for all the faculty in the Institute. This picture was sent to me by Alice. It's the same photo that she sent to the Pope, as she requested sainthood. I hope she's laughing too. And then there are always the people in a unit that just are marvelous to me, who weren't in my lab, starting with Paulette and May and Lone and Dr. Chen and Vic, who will be celebrating his 40th year next year in the Eye Research Institute, a really high honor for him as well. But these people, any problem I had, any student who had a problem, I cannot tell you how quick these people were to help me. Also had 2 recently. I've always had great technicians, but these 2 recently, Kathy, who works in the biology department, and Mary, who's still with me and who painted this picture of me and has just done fabulous work in the lab. She takes out retinas now, as did Kathy, better than I do. And then I've had this incredible array of students. If I had to do it over again, I would have been taking more pictures in the 70s and 80s. But these are 2 of my favorites, Tonya Rex and Melissa Brazel. A PhD, Tonya, and Melissa is a medical examiner in Baltimore. And just before coming to the lecture today, I got a phone call from Tonya. She got her first NIH grant. So she was happy. And then the students that have been here just in the last 8, 9 years, and many of whom are in this audience, but they all have one thing in common with all the others. They have these great personalities, desire to learn. They never question. If things don't go well in the lab, they run with it. And then my family, the personal side. Amy and Jonathan, who are here with my grandson Aiden, who will be 5 next month. Jeffrey and Ann Law and Zoe, who could not be here today, but they sent me a beautiful picture of them with a "Go Papa." And of course, Susan here. I'll have one more thing to say about her. A little bit of a closer picture up of Aiden and Zoe with their usual "We Love Papa." They're really nice kids and just a joy. And then lastly, although I'm not allowed to show one slide of her, I couldn't help myself. Oh, yeah, I know. She's probably cringing. But anyway, really, we all have families that we love and respect. But I've known Susan since I was 14. She was 23 when we met. I've been waiting for that line. But she is older, but not that much older. But you can imagine 2 kids running around New York City, teenagers. It was really great fun. And we even worked together on Fifth Avenue one summer. My father got me a job in the garment district and found out that Susan, you know, he didn't find out. I knew Susan wasn't working, and so I asked the personnel people, yeah, we can get her to work. Well, my father was not happy when he found out that now we were spending all our time together. Not a happy camper at all. Bottom line was that she's made my life ridiculously easy. I hope it will continue that way in retirement, although there are some things already that have happened, you know, that make me a little... Can I take back the buyout? So there it is, folks. On time, delivered, and you've been great. I can't thank you enough.